Hello everyone, I'm Dr. Neelima working as Assistant Professor in ECE Department. Today, I will be discussing about the topic design of combinational circuits. So this is for the second year first sem students for the DLD subject, that is Digital Logic Design subject. Now, before going to this design of combinational circuits, we will be dealing here with what is a combinational circuit and what is a basic block diagram of combinational circuits, and we will see the applications of examples or the applications of combinational circuits where it is used and design procedure, and we will be understanding the examples here with two. I will be designing here in this session the majority circuit and its implementation as well as the half adder implementation. Now, what is combinational circuits? The digital circuits are classified into two types. One is a combinational circuit and the other one is a sequential circuits. Combinational circuits are those circuits whose output depends only on the present input values. So if I give the input values, depending upon the logical function, the corresponding output will be generated here. There is no need of memory element here because here the past values are not needed here. So there is no need of memory element is required in this case. And the basic building blocks which are used to design the combinational circuits or logic gates. And here there is no feedback path exists in the combinational circuits. Feedback path is nothing but the output is connected back to the input, that we call it as feedback path. And the examples of the combinational circuits are adders, subtractors, multiplexers, comparators, encoders, decoders, code converters. All these comes under the examples of combinational circuits. But in the adder, serial adder, we cannot call it as a combinational. It is an sequential circuit that we can discuss later. Now, if you see the basic block diagram of a combinational circuit, here we have the n inputs and multiple outputs. A combinational circuit, depending upon its logical function, depending upon the given inputs, the corresponding output will be generated. For example, if you see the logical symbol here, the block diagram, it consists of 4 inputs here. And in this case, the outputs here, you are having 2 outputs. So the outputs x and y, it is a function of the inputs A, B, C, D. So combinational circuit can have a single output or it can have 2 or multiple outputs. And the inputs also in the same way, it may consist of a single input, 2 inputs or the multiple inputs. So depending upon the what type of logical function you are implementing here, depending upon that, if the input changes, immediately the corresponding output changes here. Next, if we see the examples of combinational circuits, these combinational circuits are classified into 3 types. It's an operation of combination. These are classified into 3 types. One is the arithmetic and logical functions. The other one is the data transmission functions. And the other one is the code converters. The examples which comes under the arithmetic and logical functions as adders. In adders, again, we have the half adder, full adder, 4-bit binary adder, or the adder comes subtractor circuit. We have a decimal adder, then subtractors, we have half subtractor, full subtractor, implementation of a 4-bit subtractor, or the comparators, it can be a single bit or 2-bit comparator. All this comes under the arithmetic and logical functions. Then we have this combinational circuit, other type of combinational circuits, it is classified as data transmission circuits, and the data transmission circuits examples are multiplexers, encoders, demultiplexers, decoders. All these examples comes under the data transmission operation. And the other application for the combinational logical circuits are code converters. As the name implies, code converters are used to convert one code to the another code. It can convert the binary to the gray code or gray to binary, or the BCD to XS3 code or XS3 to BCD. So these are the combination logic circuits. Depending upon its application, these are classified into 3 types here: arithmetic, data transmission, and code converters here. Before discussing about this, we'll just see how to design a simple combinational circuit. So to design any simple combinational circuit, the first step is you have to understand the problem statement. Once after identifying the problem statement, you have to decide the number of inputs and outputs required. Then you have to construct the truth table for that with the inputs and the outputs as per its logic implementation, and then you have to obtain the output expressions. To obtain the output expressions, already we are familiar with the Boolean algebra as well as K-maps. By using the Boolean algebra or K-map, you can simplify the output functions. Then you finally always remember the design ends with a logical diagram, which starts with a problem statement, and we will be writing the truth table. We will be finding the output expressions using K-map. Once you got the expressions, you have to realize that expression using the logical diagram. So once the logical diagram is implemented using the gates, you have to verify the circuit. So how we can verify? Give the different combinations of the inputs. For the given inputs, as per the truth table written, you have to check the functionality of the circuit. If the functionality of the circuit satisfies, we say our design circuit is perfect. Okay. Now, I'll explain this with a simple example, majority circuit and its implementation. Now here in this, we are designing just read the question, design a combinational circuit that accesses 3 inputs and output is 1 when the input has majority of 1s. Now here the problem is given. You have to design a combinational circuit, and that circuit is accepting how many inputs here? 3 inputs, and the output will be 1 if the input has a majority of 1s. So as per the statement, it is very clear. First, you decide the inputs and outputs. So in the statement, it is clearly mentioned that it requires 3 inputs. I am taking ABC as a 3 inputs. Then how many outputs are there? Clearly in the statement it is mentioned output will be 1. When the output will be 1, if the input consists of majority 1s, that means you have only single output, that is y. Next, we have a single output, that is y. Next, write down the input combinations here. What are the input combinations? You have 3 inputs, means you have to write down total 8 combinations: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the 8 combinations you have to write. Now, already in the statement, it is clearly mentioned the output will be 1 if the input consists of more number of 1s or the majority 1s. Now see the first combination, all zeros. All 0 means you don't have any more number of 1s, so the output will be 0. Now see the second case, 0, 0, 1, single 1. You don't, majority zeros are there but not 1. So in this case also the output becomes 0. Now see the next combination, here also output 0 because the majorities are 0. Now if it is for this combination 0, 1, 1, it consists of majority 1, so the output will be 1. 1, 0, 0, the output will be 0 because it consists of majorities or 0, not 1s. Next, in this case, the output will be 1. 1, 1, 0, the output will be 1, and 1, 1, the output is 1. So once after writing the truth table, you have to decide now. You have to find the output expression. How you can find the output expression? For that, find out the midterms. How you can write the midterms? For which value, for which input combination the output is 1, that you have to consider. So the output is 1. For which input combination? It is 3. So 3 is a midterm. Then it is 1. For which input combination? 5, 6, 7. Write down 5, 6, 7. So you have written the midterms. Once the midterms is written, you have to find out the output expression. From the truth table, you can write down the output expression directly, or you can simplify that by using the 3-variable K-map. So draw the 3-variable K-map. A, B, C are the inputs, 0, 0, 0, 1, 1, 1, 1, 0. This is a K-map representation for the 3-variable. Now, what are the midterms given? 3, 5, 6, 7 in place of 3, in place of 5, in place of 6, in place of 7. You have to keep 1. Represent the midterms as 1 in the K-map. Then you have to group the cells. Which cells I can group here? Adjacent cells. So I can combine these 2 cells. I can combine these 2. And these 2 cells can be grouped. Now, what is the output expression? Y is equal to, for this group, it is BC plus, for this group, it is A into C. Then for this group, it is A into B. So this is the output expression for the given function. Once you got the output expression, the final step is you have to implement this expression by using the logic gates. By seeing the expression, it is very clear how many logic gates are required. We need 3 AND gates and 1 OR gate is required. So we'll go for the logic diagram. So 3 AND gates and output of all these are connected to an OR gate. The output of this is Y, and here I am taking the input as AB, then it is BC, then here it is AC. This is a final logic diagram for the majority circuit where the majority ones are present. Now I want to check whether my logic diagram functionality is correct or wrong. For that, I will take any one combination of the input. What is the combination I have taken here? 0, 1, 1. I will check the functionality of my design. Now 0 into 1. What will be the output of this AND gate? It will be 0. Now this is 1, B is 1, C is 1. 1 into 1, output becomes 1. Now A is 0, C is 1. So it is 0. 0, 1, 0. For an OR gate, if any one of the input is 1, the output will be 1 for the OR gate. So what is the output here you got? Y. Check the truth table. Here the input combination I have taken is 0, 1, 1. And what is the output I got? I got the output as 1. That means my circuit, it is acting as a combinational circuit that accepts 3 inputs, and the output will be 1 if the inputs consist of majority number of ones. So in this way, you have to design any combinational circuits. Now, we'll check one more example. This is a half adder implementation. We know half adder, already I told you, design procedure means understand the statement, problem statement first. So half adder means it is used to perform the addition of 2 binary bits, and it consists of 2 outputs. Always for the adders, it consists of 2 outputs. One we call it as sum and the other one is carry. So 2 inputs, 2 outputs. So for the first thing is, once after understanding that, you have to write the truth table. Now 2 inputs means I am taking the 2 inputs as AB and the output as sum and the carry. 2 inputs 0, 0, 0, 1, 1, 0, 1, 1. 0 plus 0, sum will be 0. There won't be any carry, so it will be 0. 0, 1, sum is 1, carry is 0. 1, 0, 1. 0, 1, 1 is sum is 0, carry is 1. Now what I told you, after implementing writing the truth table, you have to find out the output expressions for the sum and the carry. For sum, what is the output expressions? For this, there is no need to go to the K-maps. Directly you can write the minterm is 1. For which input combination? A bar, B plus. It is 1 for which input combination? A, B bar. It is nothing but it can be written as A exclusive OR B. Similarly, for the carry, what is the output expression for the carry? It is 1 for the input combination A1, B1. So it can be written as directly A into B. So we got the sum and the carry, 2 output expressions. Once we got the expressions, the final step is you have to draw the logical diagram. So logical diagram, which gates are required here? You need one exclusive OR gate for the sum where the inputs are A, B, and it will be A exclusive OR B, and you need one AND gate for the carry. This is A into B. So this is the design. Now I want to check whether my circuit is working as a half adder or not. So what I give? I give both the inputs as 1, 1. So both the inputs are 1, 1. You know, for an exclusive OR gate, when both the inputs are different, output will be 1. When both the inputs are same, output will be 0. Now here for this exclusive OR gate, both the inputs are same. If both the inputs are same, the output becomes 0. So what is the sum you are getting here? Sum you are getting as 0. Now 1, 1 is given as input for the AND gate. What will be the carry here? Carry becomes 1. So 1, 1, if I am giving the input here, I am getting the sum as 0, carry as 1. Check here. Check the truth table. So you got the same thing. So my design, my logic diagram, it is working as an half adder. It is nothing but which is used to perform the addition of two binary bits, and it is generating two outputs, sum and the carry. So in this way, any combinational circuit can be designed. So simple is just you have to understand, the first step is understand the problem statement, decide the number of inputs and outputs as per the logic diagram, write down the truth table. Once the truth table is written, for the output function, find the sum of minterms. Once you got the minterm, simplify that by using the K-map. Once you got the Boolean expression, realize that by using the logic gates. Finally, verify the functionality of your design by giving the different input combinations and check whether it is working properly or not. In this way, any combinational circuit can be designed. So as a practice, you can implement a combinational circuit that acts as three inputs, but output is a square of the input here. A square of the input means, for example, three inputs means here you can write down the combinations from 0, 0, 0, 0, 1 to 1, 1, 1. And you have to decide the number of outputs required. So here for 0 square means it should be a 0. If it is a 1 square means it should be 1. Similarly, 7 square means you should get 49. To represent 49, how many binary bits are required? That you have to decide and you have to write. In the same way, you will be having a 6 outputs here. For this 6 outputs, you have to find out the output expression. In the same way, you can design the logical diagram. You can try this. Similarly, full adder design. Full adder is used to perform the addition of 3 binary bits. And already I told you, adder means it consists of 2 outputs. That is, one is the sum and the carry. Consider 3 inputs ABC, write the truth table. In the similar way, you can design this combinational circuit also. Thank you.